This is Phoebe from the Group 4 of 11 STEM 11A. Welcome to the video on the derivation of the sum and difference identities for cosine and sine. So we're going to begin by drawing a picture of our unit circle. So on our unit circle, we are going to call the origin point O. And then this point out here, we are going to call point P. And it's got ordered pair 1, 0, because it's the unit circle. The distance from the origin to the spot on the inner circle is 1. Now we are going to draw an angle. We'll call it angle B. So angle B gives us an ordered pair out here only in the circle that we are going to call point Q. And it has ordered pair cosine B, sine B. It is from the definition of the trig functions. So now we are going to put on a second angle. We are going to call this angle A. And that's going to give us a point on the unit circle that we're going to call point S. And it has ordered pair cosine A, sine A. Again, from the definition of the trig functions. So now, what we're going to do is we're going to put in a third angle in here, where we go angle A, and then we're going to take B away. So, we're going to come all the way over to angle A, and then come back angle B right inside here. And that gives us this new angle, which is in blue, called A minus B. All this is angle A, then subtract off whatever B was. And that leaves you this new angle here on the blue line, and we're going to call that A minus B. That will give you a point on the unit circle that we're going to call R. And it has an ordered pair cosine A minus B, sine of A minus B. In addition, what if we said all of this is angle A, but instead of taking B off this way, giving us the blue line, let's take B off over here from the x-axis. That's going to leave us the angle SOQ. So you see that angle right there. What's that angle? All the way over to orange is A, from the green line all the way over to A, and then you take off this B right here. That leaves you this new angle, which brilliantly enough is going to be also called A minus B. So the blue angle is A minus B, and the angle between the red line and the orange line is also A minus B, because they're the same angle. Since we're running in a circle here, these points that we have can make chords. And so, there's a chord that goes from point R to point P. So that chord right there is what's opposite to this blue, which is A minus B. And it's called chord RP, but there's this other chord that's between S and Q. And they have a certain distance. And also R and P have a certain distance. So what do you know about these distances? Knowing that this angle right here is A minus B, and this angle between the red and the orange is also A minus B. Well, these distances, these two chords RP and SQ have to be the same length, because we're all sitting at around the unit circle. All these distances here is 1. So then we know that RP notation for chord RP has to be equal the chord SQ, just because the angle opposite of those chords are the same. They're A minus B. So what's the length of chord RP? Well, you've got a point R and a point P. It's pretty easy to figure out the distance between 2 points using the distance formula. And the same idea between S and Q. If you do, it'll look something like the following. We've got cosine A minus B minus 1. That would be the x value minus the other x value squared. This is strictly from the distance formula. If you don't remember it, then you need to go refresh your memory. Then plus the sine of A minus B, this y value for R minus the y value for P would be the sine of A minus B minus 0 squared. All of this represents the distance between R and P. Well, let's equal the distance between S and Q, and the distance between S and Q is the square root of cosine A minus cosine B. The x value of S minus the x value of Q would be this thing right here, squared plus the y value of sine A minus the y value of Q, sine B squared. So the distance RP looks like this, and the distance SQ looks like this. It is really confusing to look at, but it's really just the square root of x2 minus x1 squared plus y2 minus y1 squared, the distance formula from way back when. Now, we're going to another but with a bunch of algebra. So we can square both sides or the square root. And then, what do we have inside here? We have the cosine of A minus B minus 1, and all of that is squared. Well, that's really just a binomial squared, right? That really means cosine A minus B minus 1 times the cosine of A minus B minus 1, and we're just going to multiply that out. So if we get to our next line, it'll look like the following. Cosine A minus B minus 1, quantity squared, goes to cosine squared of A minus B minus 2 times cosine of A minus B plus 1. So these first three terms right here come strictly from the cosine of A minus B minus 1 squared, and that's just multiplying the binomial squared. So we have here the sine of A minus B minus 0. Well, that's just the sine of A minus B, and then we're going to square that. And so that's where this plus sine squared of A minus B is coming from. So this part right here is just coming from this part. Then equals, and now we have the cosine of A minus the cosine of B. Well, again, this is a binomial square. This is cosine A minus cosine B times cosine A minus cosine B. And then just multiply it out. When you do that, you get cosine squared A minus 2, cosine A, cosine B, plus cosine squared B. And do the same thing with this last binomial squared. Sine A minus sine B squared. Rewrite that as sine A minus sine B times sine A minus sine B, and then multiply those two binomials together, and then you'll get your sine squared minus 2 sine A sine B plus sine squared B. So all of this blue goes to all of this mess in red. It's scary looking, but it's really nothing but a bunch of algebra. So just multiply it out and you'll see where all of this stuff in red is coming from.
So now we can do a little combining of terms. For example, cosine squared A minus B and sine squared A minus B. These two things right here, if you add them up, you get 1 because cosine squared theta plus sine squared theta is equals to 1 from one of our identities. So that goes to 1. You've got another 1 over here, so 1 plus 1 is 2. And then you've got minus 2 cosine A minus B. It's the same idea that's going to happen on the right side. So this left side goes to 2 minus 2 cosine A minus B. And then the right side, well, we've got cosine squared A plus sine squared A. Well, that goes to 1. And then we've also got cosine squared B plus sine squared B. Those also goes to 1. So 1 plus 1 gives you 2. And then you've got minus 2 cosine A cosine B. And then minus 2 sine A sine B is left over. So we can subtract 2 from both sides, and then we can divide both sides by negative 2 to give us the following. Cosine A minus B equals cosine A cosine B plus sine A sine B. This is our identity for cosine A minus B. So now we know this is true. We can use it. So for example, we know that cosine A plus B is equal to cosine A minus negative B because A plus B is the same thing as A minus negative B. Then we can use this identity that we have up here. So that goes to cosine A times the cosine of negative B because your second angle here is now negative B plus the sine of the first angle A times sine of the second angle, which is negative B. And that's going to leave you, well, cosine A and then cosine of negative B. Will recall that cosine is an even function and that the cosine of negative B is the same thing as the cosine of B. And then sine of negative B, well, sine is an odd function, so that sine of negative B is actually the same thing as negative sine of B. And so you get this negative 1 that's not here, which changes to a minus. So minus sine A sine B, and this would be our second identity. This be the one for the cosine of A plus B. I don't let all A's and B's kind of freak you out. All this is saying is the cosine of A of two angles added together is the cosine of the first angle times the cosine of the second angle minus sine of the first angle times the sine of the second angle. It's really all the same because you really cannot have A's and B's running around. You're gonna have other angles. Let's move on to difference of sine. Recall that sine of theta is the same thing as cosine shifted right. So like cosine pi over 2 minus theta, those things are equal. So we're going to use that here. So we've got the sine of A plus B. A plus B being our angle, well, that should be the same thing as cosine of pi over 2 minus the angle of A plus B. Cosine pi over 2 minus algebra cosine of pi over 2 minus A plus B, you distribute to negative 1/3, so you get pi over 2 minus A minus B, and then we're going to group them as pi over 2 minus A. We want to group that together, so we have parentheses and then minus the B. So now we've written sine of A plus B as the cosine of pi over 2 minus A. all that angle minus second angle B, we see that first angle, second angle, and then we can use our previous identity, and that's the cosine of the first angle, 8 pi over 2 minus A, times cosine of the second angle plus sine of the first angle times sine of the second angle B. So now what's the cosine of pi over 2 minus A? Well, that's just a shipwreck going back up here to our recall of our identity here. And cosine of pi over 2 minus A should be the same thing as just the sine of A. So cosine pi over 2 minus A goes to sine A times cosine B, plus same idea here. Sine of pi over 2 minus A goes to cosine A and times the sine of B. This is our third identity. This is the sum of two angles of sine. The sine of two angles added together is the same thing as the sine of the first angle times the cosine of the second angle plus the cosine of the first angle times sine of the second angle. And now that we have this identity, we can do the difference 1 sine of A minus B is the same thing as sine of A plus negative B. And now we can use this identity right above it. And that means that sine of the first angle times cosine of the second angle. So I can angle negative B plus cosine of the first angle A times sine of the second angle negative B. And then we use the fact that cosine is an even function, so cosine of negative B is the same thing as cosine B. So sine A cosine B and then sine of negative B is an odd function, so that's going to go to negative sine of B, and we're just going to change this positive here into a negative, because there would be a negative 1 that goes to minus cosine A sine B, so the sine of difference of two angles is the sine of the first angle times the cosine of the second angle minus the cosine of the first angle times sine of the second angle. So let's summarize the sum and difference identities.
Cosine of the sum of two angles, right, goes to the cosine of the first angle times cosine of the second angle minus the sine of the first angle times sine of the second angle. And the sine of the sum of two angles, you get the sine, cosine plus cosine sine. We've got a couple things to keep in mind. Cosine of the sum are the cosine of the difference, but they both go cosine, cosine, sine, sine. Follow me? Cosine, cosine, sine, sine. Whereas sine, the two sine identities go sine, cosine, cosine, sine. They alternate. So it's one way that might help you keep them straight as opposed to what identity goes with what. So you can remember the identities. Another thing we noticed is that sine of A plus B and the sine of A minus B. There are two signs whether it's an addition or subtraction. They carry over into the identity. You got a plus here for the sum, and we've got a minus here for the difference of two angles. But for cosine ones, they're the opposite. So if it's the cosine of A plus B, then you're gonna be doing a subtraction between the two parts. And if it's the cosine of A minus B, then we're gonna be doing an addition between the two parts. So you need to find some way to keep those in mind so we don't mess up the sign, which is obviously easy to do. Alright, so those are the four identities. That's it for the derivation of the sum and the difference of identities. Thank you for watching.